capacitance in spiral inductor. So let's discuss for now capacitances that are in spirals that are not close to a substrate or to the ground, and let's just define them as series capacitances, even though it does not mean that they are in series to the inductance or to the resistance. So basically there are two major mechanisms that we can see when we look at the layout of a spiral. First mechanism we can see at the right is that basically sections, strips that are adjacent to each other, they also have capacitive coupling, not just inductive coupling that we discussed before, but also capacitive coupling. We can look at two lines and understand that there's some capacitance between these lines. And we can lump all these capacitances between adjacent segments and lump them all together to be one capacitor that is connected between the input and the output of the total spiral. Of course, the full picture is a little bit more complicated, but still, if we want to analyze the inductor till the first resonance, the model will be good enough if we will just lump all these capacitors into one capacitance between input and output. On the left of the slide, we can see another capacitor. Both mechanisms contribute the same order of magnitude of capacitance between input and output. But the capacitor that we see in the left is coming from the underpath. So the underpath is a metal segment that is connecting the inner part of the spiral to the outside world. It is usually being achieved by a metal layer that is one metal below the spiral, and since it just crosses the spiral, we get let's say two plates that have a capacitance between them. And in this picture we can see two capacitors, but we can still lump these two capacitors into one capacitor. And basically we take the two mechanisms and all the capacitors that are part of the structure and lump them into one CS capacitor that is connected between input and output.